Okay, so graphing from factored form. We've been talking about equations in what form? Factored form, right? What's the other form that we know of? Huh? Vertex form, okay? And vertex form is useful because it tells us what right away? The vertex, right? What is the benefit of the factored form? So factored form, by looking at an equation in factored form, we can identify almost instantly our P and Q, our x-intercepts. Okay? So looking at model B real fast, I'm going to just skip to one thing here. What is our x-intercepts in model B? Yeah, we set this to equal 0, right? X minus 1 equals 0. Well, that means that positive 1 is our x-intercept. And what is true of all x-intercepts? Y equals 0. So 1, 0. And what's our other x-intercept in model B? Positive 5. Because 5 minus 5 is 0. So parenthesis 5, comma, and once again our y value is 0. I'm going to just plot these real quick. 1, 0, and 5, 0. I'm going to come back to Model B a little bit later, okay? I just want to recap what we did yesterday. So, Model A. Identify the key features of the graph. So, concavity is just a fancy word for which way the graph faces. Which way is our graph facing? It's up. Okay, it's up. It's where it opens. Okay? So it's open up here, so it is up. Y-intercept is where our graph crosses our y-axis, intercepts the y. So what value is this down here? -3. And what is true of all y-intercepts? Our x value is 0. Very good. So 0, comma, -3. Our x-intercepts is where our graph crosses our x-axis. I see one right here at -3 and the other one at +1. And I mentioned it a second ago, but what's true of all x-intercepts? Y is 0. So -3, 0, and 1, 0. So we already have 3 points listed. Axis of symmetry. Okay, this is very important today. I want you to focus on this part. What is true of the axis of symmetry of our graph? How would you describe it to me? Where is the axis of symmetry in our graph? Okay, you're right. It goes through the lowest or the highest point, or min or max. That's true. They have something different though, but you are accurate on that. The line of the vertex is similar to min and max, okay? So it goes through the vertex. What were you saying back there?
If it's straight or compressed?
That's the A value, is something different. Where is the axis of symmetry in our graph? The middle is what I was looking at. It's the middle of our graph. So where does this go through on our x-axis? What number is that? -1. So it's x equals -1. What do you notice between -3 and +1 going to -1? What's true of those 3 numbers? They're 2 points away. They're equally far away from -1. -3 to -1 is 2 units away. And then -1 to 1 is also 2 units away. So it's in the middle of our 2 x-intercepts. When we do Model B, we're going to find the middle of 1 and 5 for our axis of symmetry. So what is our axis of symmetry going to be for Model B? 3. Another way you could do this is add these 2 numbers up. 1 plus 5 equals 6, and we divide it by 2. We're finding the average. Equals 3. Okay? So back up to model A. I know I'm going back and forth here. Model A, last thing we have to do is find our vertex. Our vertex is at -1. I'll do this in orange. -1, comma, -4. Now what we're going to do today is when you get this axis symmetry number, you're going to take that number, -1, and put it back into the equation, and it'll spit out our y value. We don't have an equation for this, so I can't check it for you, but we'll do that down here. Okay, so model B, we have part is already done. Our axis symmetry, I will just plot that in green, right down the middle. Now, we know our vertex is somewhere on that axis of symmetry, but we don't know where yet. So take this 3 and plug it into the equation. So we have -3 minus 1 and 3 minus 5. Don't forget that negative sign out front. A lot of students forget that on the assignments. 3 minus 1 is 2. Whenever you have two parentheses next to each other like this, it's always multiplication. Okay? A lot of students also forget that. And then 3 minus 5 is? Now 2 times -2, that equals -4. Negative sign out front still. So what's the number become? 2 negatives becomes a positive. So our vertex is 3. That's our x value. Our y value is +4. So over 3 up to 4. There's 2 things left here. Our concavity. What is our concavity? Do we know from this equation? Down. It's down because we have a negative out front. Okay, it's our a value. It's -1, so we are going down. And one last thing, our y-intercept. How do we find our y-intercept? What's true of all y-intercepts? X equals 0. So just like we did down here for the vertex, when we put 3 in, you're going to put 0 in for x. So -0 minus 1 times 0 minus 5. That negative sign out front, don't forget it. 0 minus 1 is -1. 0 minus 5 is -5. Now we have a negative times a -1 times a -5. What's our answer?
-5.
Why is it -5?
-1 times -5 is +5 times the negative is negative.
Brings it back to negative. So negatives cancel out in pairs. So if there's 3 of them, 2 go away, we have 1 left. So positive, positive, doesn't matter which one you cancel out. Then 1 times -5 is simply -5. So our y-intercept is 0, comma, -5, 0, comma, -5, and now we just connect our dots. And we are